Hey everybody, this is Larry. This is Miko with Q2 of the weekly contest 438. Maximum sum with at most K elements. Hit the like button, subscribe button, join me in Discord. Let me know what you think about this one. So this one is fundamentally greedy. I think we probably have, and I mean there are a couple of ways you can do this actually. I think the way that I did it now that I think about it, it's a little bit overcomplicated. But and maybe we'll live update this to make it a little bit less complicated. But the way that I thought about it is just that we want to get the max out of the matrix as much as we can, and then if we hit the limit, we just don't. Which actually is not how the way that I implemented. I thought about it on a row by row basis, but yeah, and we'll go over the code. But I think if you just do it greedy, it'll be pretty straightforward. And I did this one in about 4 minutes, so either way it wasn't going to be that hard or that slow for me. But yeah, but basically for each row, I actually sort them in reverse order to put the maximum in the front. I put it in a deck so that I could pop it off one at a time, and then I put that on a heap where we put the value of the smallest or the largest element in the heap. It's negative so that because we have a min heap in Python, so yeah, and then keep track of the row index as well, and then that's it, right? So we want to pick K numbers. The while true loop will allow us to keep on popping as long as we are limiting, and then we just kind of add, and we see a row with under the constraint, then we just increment. We add the value. We pop it from the grid, and then if there are any more elements from that that row, we put it back in the heap. So in theory, this is slightly faster, but with the same overall constant. But it's not even that necessary, right? How I would maybe do it now that I'm kind of, I don't know, looking at it again. Let me just show you this is the correct solution, right? For a sec. And then if I were to do it again, then I would just not even bother with all these things. I would just put everything inside. And then I would I for the index, and that's it for the heap, right? Counts, maybe we could keep track of count. But then here, yeah, maybe the same idea, right? But just gets rid of a bit of complexity, right? We look at the value and index. Actually, this is very similar. I don't even have to update any of this. I don't need to do this, and I don't need to do all that, and that's it. So actually very similar, even though my code is slightly more optimized before technically, possibly, but it should be mostly good, right? It's just, yeah, and the complexity is going to be n log n. Keep in mind that n is the number of elements in the matrix, which is r times c, so it's going to be n log n. Where the other one is, we do a sort on each column of row, so it's going to be r times c log c. So the constant is going to be log c instead, so it's going to be n log c, right? So it's log c instead of log n, which is a little bit faster, but for the sorting. And then, yeah, but the constant's a little bit higher because you have to do with decks and stuff like that and queues. Let's take a quick look to submission time. I'm curious. So 875. So yeah, the way that I did it is twice as fast, more or less, give or take. But the complexity is so much less, right? And you don't even have to worry about it that much. So maybe this is a little bit cleaner. I don't know. Let me know what you think. So yeah, this way is going to be n log n. The other way appears to be n log c. Yeah, because you have at most, n. Well, this part, the top part is going to be n log c. But the bottom part is actually n log r, because for each item, you always push or pop the number of rows in that heap, right? Wait, no. Oh, yeah. I mean, the same thing up here before, but yeah, so I guess it's just n times log r plus c inside. So it's a little bit faster, but not by that much. So I wouldn't really worry about it. Yeah. Anyway, that is all I have for this one. Let me know what you think. It is greedy because you always want to get the max element, and you can get it. You just take the next one that you can, and you can prove this by the exchange argument, by the way, by swapping in another number and then playing around, be like, nope, that doesn't make sense. and then you can figure it that way. But yeah, that is all I have with this one. Let me know what you think. Thanks for watching. Stay good, and you can watch me solve it live in the contest next. Probably okay. YOLO submit. Okay, good. Probably could have taken an extra 20 seconds on that one, but I don't know. All right, let's go. 2D matrix, limits, integer k, maximum and most k elements in the graph such that the number of elements in the ith row does not. Okay, so you can only take these number. Okay, it's still going to be just heaps, right? I mean, I don't think there's any difference other than yeah, heaps or sorting, whatever. Yeah, okay. Yeah, okay, whatever. And this is a typing problem, so gotta get it quick, I suppose. Just don't make a silly mistake. Right, and then we just have a heap. Right. Grid sub I of 0. Oh, this is an I. That's why I was like wondering where the O came from. Grid sub I and then I, right? We'll maximize or minimize. Maximize. So that means that we want the negative. Okay, fine. Right? Yeah, we're good. And then now for we want to take k of these, right? We want to say limits up. I mean, it's fine. We just have to keep track, right? Maybe just counts of. I mean, you could probably do this implicitly, but I want to do this explicitly. Okay, so then now the q.heap_pop of h will give us the value and then the row number, right? The value doesn't matter yet. I guess it does, right? So then now if index or if counts of okay, while true, we have this thing we want to pop. If the count is less than limit sub index, then we are good. Then we just and then we add it by the negative v. Otherwise, we have to put the next number in the heap. Yeah, so then now grid sub index dot pop left, and then we have to go if length of grid is if length of grid is greater than 0, then we push it back into the heap. And otherwise, that's it. Otherwise, we don't do anything. It just pop again and get another one because it is over the limit. Deck index out of bounds. On which one? On this one? Oh, it's quit of index. Whoops. Okay. Oh, I have to break here. 721, probably okay. Wait, double check. K could be all times C, which is 2500. That should be okay. All right, let's go. If it times out, that'll be a little bit sad, but I think that should be okay. Okay, we're doing okay. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem, this contest, these explanations. Yeah, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.